This video covers section 7.3, the unit circle. Our goals today are to find function values for sine and cosine of the common angles and to use reference angles to find sine and cosine for standard unit circle angles, as well as identify domain and range of sine and cosine. Okay, tangent we'll do in the next section. Briefly, some quick reminders about the special triangles. I did mention that if you wanted to write it as a ratio, you could write it like this. Okay, and then this one was 1 to 2 to root 3. So um, these are the same, they are just tilted on a different side. Okay. Then as for the quadrants, keep in mind that in quadrant 1, everything is positive. In quadrant 3, everything is negative. In quadrant 2 and 4, we have a positive and a negative, right? So those alternate. And a quick reminder that it's going to be cosine, comma, sine, the way that we had x, comma, y. Okay. And then remember the quadrantal angles. Okay, we have quadrantal angles. The one down here is missing. It is 270 or 3 pi over 2. The rest are provided to you. All right. Use a graph to find the points of the intersection between x squared plus y squared equals 1 and y equals negative x. So the first one is going to be a circle. Okay. It's going to be at the origin and it's going to have a radius of 1. I'll go ahead and add a circle that is much larger than what I was hoping for. So let's make that adjustment. Okay. And then the other one is going to be a line starting at 0, going down 1 and over 1. Okay. So if we are looking for the intersection, okay, we're looking for where those points are crossing and touching. So those two red points are going to be the values of intersection. Okay. Now, it's roughly, let me see if I can adjust slightly here, the circle. There we go. Roughly going to be -1, 1 and +1, -1. Okay, those are roughly going to be those points. Not on the graph, it's roughly, but the coordinates are going to be -1, 1 and 1, -1. Okay. All right. Trig functions allow us to connect each angle t with its coordinate on the unit circle. Remember that the radius is going to be 1 on the unit circle. Okay. If t is any angle in standard position, then the arc length is equal to t, and the terminal ray passes through that point. Okay. So, for example, let's go ahead and find the exact values of cosine of 5 pi over 3 and sine of 3 pi over 2. This is the filled out unit circle. Okay. So when we look for those exact values, we're going to see that they're already provided to us at 5 pi over 3 here and 3 pi over 2 here. Okay. But first, let's briefly kind of talk about some of these observations. In quadrant 2, oops, cosine is less than 0 and sine is greater than 0. We've already talked about that. In quadrant 4, it is the opposite. Okay. And then again in quadrant 1, cosine and sine are both positive. And in quadrant 3, they are both negative. Okay. Now, if we're looking for exact values from here, from earlier, we are interested in cosine. So keep in mind that this is cosine and this is sine. So cosine of 3 pi over 2 is equal to 0. And, oh, I'm sorry, we were looking for sine on that one. And then sine of 3 pi over 2 is equal to -1. Okay, I'll go ahead and highlight that one. Then for this guy, since I did both, I'll go ahead and do both. Here we have cosine, here we have sine. So cosine of 5 pi over 3 is equal to 1/2. Okay, all right. Oops. Now, at some point, you will have learned this entire unit circle. Right now is not that moment where I talk to you about how to learn it or how to memorize it. I don't like the word memorize. I think you'll really actually end up learning it. But now is not that moment. We'll talk about that in a little bit. Okay. So the range of cosine is the horizontal diameter of the circle, -1 to 1, and the range of sine is the vertical diameter. So if you look at what's happening vertically, we don't go past +1 and -1. And if you're looking horizontally, we don't go past -1 and 1. Okay. So our range of each is still -1 to 1, including them. Okay. Then we also have the coterminal angles. Those are angles with the same terminal side and standard position. Since sine and cosine really only depend on the terminal side, they're always uniquely defined. Um, and so then also the domain of both of them will be negative to positive infinity. Okay. So that means you can really add any number of rotations and get that same function value, right? I could do several loops around this circle and just go however many times I want. But if I stop where pi over 3 exists, even though I've done several loops, it's going to be much more than pi over 3. It still has the same function values of 1/2 and √3 over 2. Okay, so that's what that's saying. So let's find exact values of cosine 450 and sine of -45. So for cosine of 450, let's just go ahead and subtract 360 so then we can get something within 0 and 360 degrees. Okay, that's going to end up being 90. So we're going to work with cosine of 90. I know that cosine of 90, based on my unit circle, is going to be 0. Okay. If I'm working with sine of negative something, right, I want to add 360 in order to get between 0 and 360 degrees. That's going to be sine of 315. Now, looking at sine of 315 right here, I notice that that's going to be negative √2 over 2. Okay. Obviously, right now you have the unit circle in front of you. In the future, you won't. And so it's going to look a little bit different. You're going to have to remember, okay, what is pi over 3? What's pi over 4? What's pi over 6? And where do those go? Okay. And that might not mean anything to you yet, but it will later. Okay. Start off by learning the big five: 0, 30, 45, 60, and 90. Okay. That is a really good starting point. Now, all of this is on the unit circle, so I'm really just rewriting it into a table. Cosine at 0 is 1, and sine will be 0. At 90, it's the opposite, so 0 and then 1. Okay. Cosine for 30 is √3 over 2. Sine for 30 is 1/2. It is the opposite for 60, right? And this is all from the special triangles. And then pi over 4 is going to be √2 over 2 or 1 over √2. I honestly don't have a preference. Um, I think sometimes the homework makes you rationalize. So I think we're used to seeing the one on the left more often, but I'm personally fine with either. Okay. All right. Now, there's a couple of patterns that we're going to be working with. Okay, we know Pythagorean theorem pretty well. A squared b squared is c squared. So that kind of applies to what we're going to talk about in the unit circle, where we have x squared plus y squared equals 1. Okay. Remember, where x and y are cosine and sine, respectively. Okay. So instead of saying x squared and y squared, we're going to start saying cosine squared and sine squared when added together equals 1. Okay. Okay. Now, suppose that sine theta is a half. Find all possible values of cosine theta. Identify an angle for each answer. So let's go ahead and plug in what we know from this equation. We have sine squared theta plus cosine squared theta equals 1. So this will be 1 half squared plus cosine squared theta equals 1. 1 fourth plus cosine squared theta equals 1, or cosine squared theta equals 1 minus a fourth, which will be 3 fourths. And when we take a square root, we will have a positive and a negative root 3 over 2. Okay? Now, that is all possible values of cosine theta. We have a positive and a negative, because if we were to graph this, we would have an option here and an option here. Because this is, here's your sine of 1 half, and then here is your cosine of negative root 3 and positive root 3 over 2. Okay. Now looking at the unit circle, which I know in the back of my mind, I know that on the right side, we're working with 30 degrees or pi over 6. And on the left side, we're working with 150 degrees or 5 pi over 6. Okay. So those are our two potential answers, positive root 3 over 2 and negative root 3 over 2. Our second pattern is working with reference angles. Okay. Um, Ultimately, if you are unsure of what to do, try to revert back to quadrant 1, the reference angle. Okay. The reference angle is always in quadrant 1. So the nice thing about if you're in quadrant 1, your work is already done. You just solve the problem. If you are in quadrant 2, if you are here, you are going to take pi minus the angle, or 180 minus the angle. Okay. If you are in quadrant 3, if you are in quadrant 3, you're going to take the angle and subtract pi, or 180. Okay. And finally, if you're in quadrant 4, you're going to take 2 pi minus the angle, 2 pi minus the angle, or 360, right? If you're working in degrees. That ultimately gets you back to the reference angle, right? Once you have the reference angle 30, 60, 45, you're like, oh, I know about my special triangles. I can figure this out based on my reference angle. Then you can just kind of mirror it over whichever axis and figure out your function value. Okay. So let's go ahead and find these reference angles for 4 pi over 3. Okay. You should immediately notice if it's a denominator of 3, it's going to be a reference angle of pi over 3. Okay, this is your reference angle. If you see something over 6, you know that your reference angle is going to be pi over 6. Okay, very straightforward. Now, if you do this algebraically, you need to think about, where am I on the unit circle? This guy is in quadrant 3. So if I'm in quadrant 3, I'm taking 4 pi over 3, and I'm subtracting pi, which is going to require a common denominator. Okay, that's going to go and turn into subtracting 3 pi over 3, which does yield the pi over 3 that we got earlier. Okay. It makes it would require a little bit more math on the degree side, to be honest, because you don't have a denominator that gives it away. Okay. When you have a radian measure, it's actually, I think, a little bit quicker because you see the denominator and you know what you're going to do. Okay. So let's do that for 210. I know that 210 is more than 180 degrees. So that means I am again in quadrant 3, which means I'm going to take my angle and subtract 180. When I subtract 180, I get 30 degrees. That tells me my reference angle is that 30-degree triangle. That also tells me I know enough about my special triangles that I know that this is a 1, this is a 2, and this is a root 3. I also know that this is my adjacent side, my opposite side, and my hypotenuse side. So I know that cosine of 210 and sine of 210 are going to be based off of those three values. I just need to think about if it's positive or negative. In this case, they're both negative. Cosine will be negative root 3 over 2, and sine will be negative 1/2, right? I'm using the reference angle in quadrant 1 where everything is positive, but 210 is down here in quadrant 3. Okay. Let's find the reference angle for negative 10 pi over 3. Okay. Negative 10 pi over 3. Let me switch colors really quick. Okay. Negative 10 pi over 3. Let's add pi. Okay, we're negative. Let's try to get positive. Negative 10 pi over 3 plus 3 pi over 3. I already see that I'm still going to be negative if I do this. Okay. So what I think I'm going to do is go ahead and add 2 pi so that I can just circumvent having to do it all over again. Okay. Um, it looks to me that that's going to continue. Okay. So let me just add another 2 pi. Okay. So now I'm adding 12 pi. So negative 10 plus 12, 2 pi over 3. Okay. This has the same function value. Okay. This has the same function value as negative 10 pi over 3. Okay. I also know that if it's a pi over 3, that I know that this is 60 degrees right here. That means I know that this is a 1, this is a root 3, and this is a 2. I know that my x is negative. Okay. So now I have sine of negative 10 pi over 3 is root 3 over 2, and cosine of negative 10 pi over 3 is negative 1/2. Okay. That covers it for section 7.3.